Alrighty, in this video we are going to be solving the wonderful looking integral that you see on screen now, and we are going to be doing so by making use of a nice Feynman's trick. So the first thing that we are going to need to do is come up with our integral function. In this case we're going to call our parameter a, and a nice one that's going to work well here is going to be the integral from 0 to infinity of the arc tangent of a times x over x times alpha squared plus x squared dx. And then in this case, our target integral is just going to be I evaluated at alpha. Oh yeah, the other thing here is that alpha is greater than or equal to 0. And pretty conveniently, this also means that I of 0 is going to be equal to 0 because this entire this will just be a 0 in the numerator here, which will make this whole fraction collapse. Cool, so we can go ahead and differentiate this on both sides. So on the left-hand side, that's easy. That's just I prime of a. On the right-hand side, that's going to be the derivative with respect to a of this thing. Arctangent ax. X alpha squared plus x squared dx. We're going to have no problem here swapping the order of the integration and differentiation, because on the bound 0 to infinity, this whole thing is going to converge, no problem. So we can go ahead and do that switch up, make that a partial derivative of a arc tangent ax, and then this whole denominator here is going to be constant when differentiating with respect to a, so I'm just going to pull it outside over here like so. Cool, so we can just go ahead and evaluate that. So this is going to be 0 to infinity. We're going to have an x up top here, 1 plus a squared x squared multiplied by 1 x squared plus x alpha squared plus x squared. Nice cancellation going on here, and we can go ahead and write this as 1 over 1 plus a squared x squared alpha squared plus x squared dx. And what I'm going to do quickly is pull out this 1 over a squared from here as a constant. So this will just become 1 over 1 over a, well, yeah, 1 over 1 over a squared plus x squared, and then this is unaffected dx. Cool, now this looks like a good candidate for a partial fraction decomposition, so we can have a over 1 over a squared plus x squared plus b over alpha squared plus x squared. We can go ahead and do this. This is going to be alpha squared plus x squared times a plus b multiplied by 1 over a squared plus x squared, and that's going to be equal to the numerator, in this case 1. We can go ahead and solve this quite easily using just comparing coefficients. So we know that all the stuff with the x squared must sum to 0. So in this case, it's just a plus b is equal to 0. And all of the stuff with these alpha and a constants must just sum to 1. So that's going to be a alpha squared plus b over a squared is equal to 1. Cool, so this implies that a is equal to minus b, so we can solve using this equation quite easily. We can say a alpha squared minus b over a squared, sorry, not b, a, my apologies, over a squared is equal to 1, which implies that a will be equal to 1 over alpha squared minus 1 over a squared, and b will be 1 over a squared minus alpha squared. Cool. So those are our two things. So I prime of a is going to be, where is our, here we go. So 1 over a squared on the outside here. And then let's do the a first. I'm going to put it outside because these are all constants. So 1 over alpha squared minus 1 over a squared. multiplied by the integral from 0 to infinity of 1 over, we can actually go ahead and bring that a squared up top here, 1 plus a squared x squared, so that's good, dx. And then our second one here is going to be, we can go ahead and bring this minus outside here and change these signs, which is going to let us do minus 1 over alpha squared minus 1 over a squared integral 0 to infinity of 1 over alpha squared plus x squared. I am running out of space here, but it should be fine. I could probably just erase this now, because we got it down here. Dx. Cool, that should be everything here. So this leaves us with two very simple integrals that we can go ahead and evaluate. The first one is going to be a squared times the integral from 0 to infinity of 1 over 1 plus a squared x squared. So that is just going to become, we're going to get a multiplied by arc tangent ax from 0 to infinity out here, which is going to be a pi over 2. Our second one here is just going to be integral 0 to infinity 1 over alpha squared plus x squared dx, which we're just going to have a 1 over alpha out here, also arctan of x over alpha from 0 to infinity. And this is just going to be pi over 2 alpha. Cool, so these are our two lovely simple integrals done. So this is going to mean that, okay, so first up here, we can pull out these. We can pull these out front and combine them with this. So that's just going to be 1 over a squared alpha squared minus 1. And then inside, we're going to have a pi over 2 minus pi over 2 alpha inside here. And now we can just go ahead and combine these if we multiply top and bottom by alpha here. So that's going to be 1 over a squared alpha squared minus 1. And inside here we're going to have pi common a alpha minus 1. That's a terrible closing bracket. All over 2 alpha. Cool. And you've probably noticed that this can be expressed as a difference of two squares, which is nice and convenient, because it means if I combine these into 1, pi a alpha minus 1, we get some lovely cancellation here, and we just have pi over a alpha plus 1, and I'm forgetting the fact that I also have a 2 alpha out here from this. All right, so the final form of this is going to be pi over 2 alpha times a alpha plus 1. So now all we have to do is integrate with respect to a on both sides here to recover the original function. So I of a is going to be, we have some nice constants to take out here. Integral, let's just do this properly. Integral of 1 over a alpha plus 1 dA, which is going to be pi 2 alpha natural log of a alpha plus 1, and we can't forget about the fact that we're going to get an excess 1 over alpha from this inside here, so this will become pi over 2 alpha squared plus that c, but we know that I of 0 is 0, so we don't actually have to worry about that. That c is just going to fall away. And this means that I of a is pi ln a alpha plus 1 over 2 alpha squared, and we can recall that the target integral I is just this integration function evaluated at alpha. So all of this is to imply that the integral from 0 to infinity of the arctangent of alpha x over x times alpha squared plus x squared dx is equal to pi natural log of alpha squared plus 1 over 2 alpha squared. Isn't that a beautiful looking result? Cool. Thank you for watching.